In this lesson, our objective is to understand and use three methods to designate sets: description, listing, and set builder. A set is a collection of objects, living or non-living. The objects belonging to that set are called the elements or the members of that set. In other words, they belong to that set. So let A represent the days of the week. Let's set A. So let's say we have set A includes the days of the week. And so here they are. Here's set A, and there's all the days of the week. So that means every member inside that set, they're called elements, or they're members of that set. We can write sets using three different methods. Method one is called the listing method. And with the listing method, you are simply just writing the sets in order from least to greatest. So for example, here you have a set that includes the numbers 2, 4, 6, and 8. Another way we can write sets is word description. And for the word description, it is simply just a written form which starts with the set of. For example, this one, we would say that this is the set of even counting numbers less than 10. So to write it in word description form, you would say the set of even counting numbers less than 10. Another way where you can write that same set is what we call set builder notation form. And to write it in set builder notation form, you're simply writing the set, and then you're going to write the criteria for which the element qualifies to be a member in that set. So let's focus on the set A that we've been working with. Remember that one where it's a set of even counting numbers less than 10. Well, let's write that in set builder notation form. When you write that, it's going to look like so. And the way you would read that is, it is read as set A is the set of all X such that X, and then it has the criteria afterwards. So here's the criteria to be a member in this set. You have to be an even counting number less than 10. So again, writing it in set builder notation form is nothing more than, again, set A is the set of all X such that, and here is the criteria, is that to be a member of this set, you have to be an even counting number less than 10. And that's how you write set builder notation form. So other requirements for a set: when we write a set, we write the set within a pair of braces. Other things about a set: with each member, you make sure that you separate each member from the next with a comma. Also, sets are commonly given capital letters as a name. So make sure when you name the set that you use capital letters and not lowercase letters. Now, if you see a member in the set that repeats itself, when we want to count how many members in the set, or when we want to write the set, we don't need to write it twice. You have to think of them as members or as objects or people. For example, let's say number 1 and 2 are people, and I want to know what are all the members that are involved in the set. Then you would just say the only people involved are just number 1 and 2. There are no other members of that set, so you do not write the members twice if they appear, just once. Other things about a set, we're going to talk about the ellipsis, and so with some sets, it might have a lot of members in it, so many members that rather than to take the time to list them all, we use ellipses, which are 3 dots, and it's basically to shorten the set, which indicates that the set continues. Whatever that pattern is, that it does continue. Okay, just like we did in a previous section with the sequences of numbers, anytime you see those dots, then that indicates that that set still continues even though we don't have to write them all out. So for example, in this set A, it includes all the 26 letters of the alphabet. Even though you may not see all of them here, you see from A to E, and then you see Z. But it does include all of the sets. Those ellipses indicates that it does include all the set. Again, it's just a shorthand way of writing sets that have a lot of members in it. You don't have to list them all. You can just list some of them as long as you include the ellipses to indicate that there are more members in that set. Now, when the ellipsis comes at the beginning or the end, then that means that the set will go on to infinity. So for example, in set B is going to include all of your negative numbers, not just from negative 1 through negative 5. It's going to include all your negatives. And then set C, it doesn't just include 3, 6, 9, and 12. Set C is going to contain all your multiples of 3. We've just only listed 4 of those members, but the ellipsis indicates that it still goes on and on, so there are several other members included in that set. The set that doesn't contain any elements is called an empty set. It's empty because there's no members in there. It's also called a null set, and it's denoted by using braces that are empty or the circle with a line through it. So you can use either of those again to indicate when there are no members in that set, or that set doesn't contain any members. So for example, express the following in listing form. So here is written as set builder. So X is such that X is an even integer greater than 4 and less than 6. So to be a member of this set, when we list it out, the criteria to be a member is that you have to be an even number, you have to be greater than 4, and you have to be less than 6. So let's think of even numbers. So even number greater than 4. So we can't include 4 because it said greater than 4. So let's go to the next number. The next number is 5. 5 is not an even number. Let's go to 6. Well, 6 is an even number, but 6 is not less than 6. The criteria to be in that listing set is you had to be smaller than 6. You can't include 6. So therefore, there are no other possibilities of getting that number. So that means there are no members in that set. There's no members to list out. So the answer to that is the empty or null set, meaning there are no members in that set. Another example, set D is going to contain the days that contain 26 hours. So, of our days, or days of the week, or whatever, how many days do we have that contains 26 hours? There are no days that contain 26 hours because each day is 24 hours. So therefore, there are no elements in set D. Okay, it's time for a checkpoint. We want to write a number from description to listing. So in other words, you're given the set in a description method, and we want you to list the numbers out. So which is the set of all whole numbers greater than 6 and less than 10. So it said greater than 6, so that means it cannot include 6. So we can already cancel out choice C and choice D. Less than 10, so that means it cannot include 10. So that means A and C are gone. So the correct answer is D. We were looking for the set of whole numbers where it is greater than 6 and less than 10. And there you have it. Checkpoint 2, this time you're given the set in set builder mode and you're going to list it out. So if you want to pause the video for a moment and read it and then decide which one is that set in listing mode. Okay, so set builder here, it says X is such that X is, so here's the criteria to be a member in that listing set. You have to be a counting number less than 2. Less than -2. Yes. To be a member, you have to be a counting number less than -2. In other words, smaller than -2. So, is it A, B, C, D, or none of these? Okay, and the answer is empty set. So first of all, let's think about this for a moment. Counting numbers starts with 1, 2, 3, and goes on and on and on. So if you are less than -2, that's like -3, -4. It's these numbers. However, these are not counting numbers. So therefore, there are no members in that set. Counting numbers are 1, 2, 3, and so on. They are positive numbers. And there you have it.